Hi guys, welcome to a very quick snappy one. This is a video on how to fill out the air source heat pump noise level calculation form. Okay, so every heat pump installation needs to have planning permission. It can have permitted planning, which means no application needs to be made, if the nearest habitable room of your neighbour to your heat pump has a sound level below 42 decibels. So what we essentially have to do in this room is work out how noisy our heat pump is and work out how much noise is going to be received at their nearest habitable room. So that means living room or bedroom, not bathroom. And that noise level has to be below 42 decibels. 42 decibels, to give you an idea, 40 decibels is the sound of a quiet library. 50 decibels is the sound of a fridge, the fridge that's in your kitchen. So without further ado, we've got a heat pump here. Let's go and assess ours. Okay, first thing to do is head over to heatgeek.com. I'll put a link in the description to find your air source heat pump noise level calculation form. You've basically got two halves. First half is the boxes you fill out, and the second half is how to fill out the boxes. It's very straightforward to just follow yourself. However, if I just explain how to do it now, it'll be even quicker. The very first box is step 1. From manufacturer's data, obtain the A-weighted sound power level, blah, blah, blah. Basically, you have to find out how many decibels the heat pump produces. Now, heat pumps will normally have 2 decibel ratings. 1 decibel rating will be at full tilt, max output, and 1 will be at reduced noise level. Ignore the reduced noise level one, it's not the one we use for this calculation. So this heat pump produces 54 decibels when the flow temperature is 55 or 65 and it's 7 degrees outside. It produces 53 decibels when it's 45 degree flow temperature and 7 degrees outside, and 51 decibels when it's 35 degree water temperature and 7 degrees outside. So you have to know what sort of system temperature you're designing for. But if we just assume worst case, which is normally fine, 54. So we're going to put 54 in our very first box. Pop 54 in there. Right. For the rest of it, we head up to the heat pump. Oh, grab a tape measure. Don't forget your pen. Grab your pen. Okay, so what we're measuring here is the sound level that's going to be present at the nearest habitable room. Habitable room means any room except for a corridor or a toilet or a kitchen. So bedroom or living room essentially, or dining room. Step 2 is a sound pressure level. Sound pressure level. Go to note 3. It's just a table you copy off. Here's step 3. Basically, if you've got one surface, i.e. the floor, or a wall if it's hung on a wall, your number is 2. If you've got 2 surfaces, such as this, because there's one behind as well, our Q is 4. If we've got 3 surfaces, like it's chucked in a corner, our Q is 8. So we know we've got 2 surfaces, so our Q is 4. Pop that in the box. Very simple. Next step, measure the distance from the heat pump to the assessment position in meters. So for our next door neighbours over there, I need to measure from here to their window. And actually, I'll meet you over by their window now. Okay, so our nearest windows, in fact, none of them are habitable rooms. We've got a kitchen there, a bathroom here, and kind of a utility here. The nearest habitable room is that one up there. So that's obviously a bedroom. So the way we measure the assessment point is we find the middle of the window up there, measure 1 metre away, and that point there is our assessment point. So we have to get up there, measure over to our heat pump, which I'm going to do now, and jot down the distance to the nearest surface of the heat pump to the assessment point in metres. Okay, so I've just measured along the ground here. It's about 5 metres. Let's say it's 6 metres because it's up there. Obviously, when you do it, you have to do a more accurate measurement. Let's pop 6 metres in this box. So the next step is the noise reduction factor. So that's a simple case of following this chart here. If the distance from our heat pump to our habitable room's window is 6 metres, and our Q from step 2 is 4, 6 metres, step 4, 20. So we have to pop in there minus 20. Step 5 is to ascertain if there's any solid barriers between the heat pump and the window. Solid barriers are either a normal fence or a brick wall. So let's head over to our heat pump and just see if we can see this window from there. Right, now I can't see that window from this heat pump from any position. So for the next box, I fill in minus 10 decibels. If, however, I could see that window 250 millimeters away from the heat pump, and I can see the window, then I'd put -5. If I can see the window at all, then there's no minus figure to put in at all. So it's, if you can see the window from 250 millimeters away from the heat pump, add -5. If you can't see it at all, add -10. And if you can see it, put 0. Step 6, calculate the sound pressure level. To calculate the sound pressure level, we add step 1, 4 and 5. Step 1 is 54, step 4 is -20, step 5 is -10. The answer is 24, A for absolute. Right, next, step 7, background noise level. We have to put a noise level that's an expected average normal background noise level. You always assume 40 decibels here. I don't know why it's in here, but it still asks you to put it. So you always put 40 decibels. Step 8, -7 from 6. 40 minus 24 is 16. And that 16 number is basically the noise difference level between the heat pump and the normal background level is 16 decibels. For step 9 here, we take that difference between normal background level and the heat pump level, which is 16, against this chart here. That actually leaves this chart because it's such little noise, but let's just put 0.1 anyway. And we add that 0.1 to our 40. Then we have to round up, 41 decibels. Provided this is below 42, we don't have to apply for planning permission. So the answer is yes. This is then kept as our proof that we don't need planning, and job's done.
We are so excited to be facilitating exclusive training for the next generation of heating masters. The Heat Geek courses are designed to take you from heating installer to heating god, with the ability to design hydronic systems from scratch, massively increasing your value as a heating engineer, and earn yourself a recognised certification. Let us teach you the skills you need to charge more for your services and future-proof your career.